I'm Brian Beliveau. I'm an assistant professor at the University of Washington in the Department of Genome Sciences. My curiosity for science is something that probably goes back to certainly my childhood, but I think became really active in a way I didn't expect when I was working alongside my father as a teenager. So he was an electrician, and that's a really fascinating and difficult job, as I learned the hard way. Just so much problem solving of how would you get a wire from here to there without damaging the walls or making a mess. A lot of problems that seemed impossible to my mind, and learning how he and the other folks that work with him kind of tackled these problems got me interested in problem solving. And then through chemistry, math, physics, biology, I learned about other outlets for problem solving beyond just the electrical work. And that's kind of what springboarded me on eventually to doing genetics and microscopy. So what got me interested in my current field? I think I became fascinated by chromatin and transcription early on, honestly as a high school student, in part because I was maybe at the right time, right place. There were amazing advances happening I really didn't know about, honestly, being a high school student, not yet connected to the literature, that were kind of setting themselves up, or I was going to be placed well, so to speak, to be in grad school a few years down the road to engage with. But the most timely thing around that, of course, was for me coming up in the late 90s is the completion of the human genome. So that's something that was very much in the for folks that were interested in science and were fortunate enough to have access to teachers that could provide excitement about things happening in the world related to science. A big part of our experience, we used to have readings from the genome, tongue-in-cheek a little bit, in one of my high school biology classes every other week or so. So it was fun to get thinking about what are all these letters, what do they mean, where are we going to put them, how did they get accessed, how could we sequence them? Lots of questions really arose from just thinking about that kind of simple starting point. So a lot of what we think about nowadays, what I'm really curious about in terms of what our lab is doing and the kind of science I like to pursue when I go to conferences or read papers, is still somewhat centered on this big question of how all the things that need to fit into little places manage to fit and do the things they do. It's something that maybe it's just a bit of my lack of mental reasoning capability. I just can't picture it. And that's one of the reasons using a microscope is so fun, is I don't have to make my mind necessarily do the gymnastics. We can spend some time really carefully try to put together a labeling scheme, design an experiment, and try to get quantitative data that we can measure and do math on and all the fun stuff. So if I had superpowers and I had to improve something for the benefit of the scientific community, that's a tough question, because I think there's so many ways to answer that question. So there are things within science itself. I would like certain techniques to be better. I'd love to be able to image more things more quickly. I'd love to have better resolution. I'd love to be able to sequence things more cheaply. I'd love to be able to amplify proteins and have mass spec be more sensitive. And then there's also kind of a separate side of how you'd answer a question like that, which is how science is structured right now. So I'd also just love to see the conversation continue to happen about how science is funded, how much funding priority science is being given, how we're supporting our trainees and the folks that are navigating careers in science, both in academics and industry, especially given some of the challenges of inflation and other constraints that are making it harder for people to get in and get going right now. My curiosity will probably take me to places I don't expect as next steps, and that's part of the fun of doing this as a job. What I'm working on now, 5 years into being an assistant professor, is somewhat what I said I would do and thought I would do, and some of it is very different. We're doing techniques I've never done before. I'm learning a whole lot, and My guess is that we will continue to kind of push into new areas and try to bridge what we can do with the techniques that we know well, like microscopy, molecular biology, sequencing, into newer areas that are places we haven't gone yet.